Hey, welcome to our lesson. So this video is going to be based on a subtopic of the topic formulae, equations, and inequalities. This video will just take a look at formulae or subject of the formula. For you to do these other things like equations and inequalities, you need to understand subject of the formula. So we're going to start with subject of the formula, then we'll explore the others. So this topic is a bit long and it has different parts and it is interconnected. What that means is each topic depends on the previous topic. So let me just say that again. Each part or each subtopic depends on the previous part or previous subtopic. So for example, for you to understand equations, you need to do this part. You need to be good when it comes to subject of the formula. So that's how the topic map works. So start with subject of the formula. When you are done, we're going to take a look at equations, introduction. Then we'll go to linear equations. Then we'll go to quadratic equations. Then when we are done with quadratic equations, we'll go to this side. We're going to take a look at inequations. And then finally, graphs of inequations or inequalities. So how this work is, if you are good at something, you can skip. For example, if you are good at subject of the formula, you can skip this part, you can go direct to equations, introduction. If you understand the basics of equations, you can skip this part, you can go and take a look at linear equations or quadratic equations. It can also happen that you are just good when it comes to equations. You can skip everything here. You can follow this route, which leads to inequations. So you can do inequations. So this is for some people who already have some knowledge about certain things. But for those who want to learn without missing anything, then you have to follow the map from the beginning up to the end. So let's get started. So the way we're going to learn this topic, subject of the formula, we're going to use an approach that I like to call as cases. So we're going to have different cases or different scenarios of questions and how to solve them. So we're going to start with something simple, then we'll be building. We'll take a look at all the cases. Then from there, we should be knowledgeable at the end. So we're going to start with case 1, quote insertion, case 1. So case 1 is a case that has addition and subtraction. So usually there is a variable, then there is plus or minus, then there is a number or another variable, and of course equals to something else. So in all the cases, our job will be to make, our job is going to be to make X subject of the formula. So we're going to understand what subject means, and then we're going to learn how to make X subject. So these are the different ways in which this case can be presented. The first is a plus x equals b. The other one is x plus a equals b. Remember, our interest is x. So in the second case here, the x is on the left-hand side, and these other things are on the right-hand side. Then the third case is the same as the first and second case, just that we have negatives between the subject, the thing we want to make the subject, or the variable that we want to make the subject, and the other term. So whenever you want to make x as the subject and you have such an expression, this is what to do. So we have a plus x equals b. A plus x equals b. So what it means to make x subject of the formula is we want x to be on its own. So wherever x is going to be, it should be without other terms. For example, in here we have a plus x. So x is not the subject because it has this. So in this case, b is the subject because it is not with these other things. So that's what a subject of the formula might mean in simple words. So your job is to make x be alone. So how do we make x a subject? So whenever you have this case, which is case 1, what you have to do is you take this A to the other side. You take this A to the other side. But a price has to be paid. So when this term, or let's say if it was a number, if this was 2, whatever, it can be a number or a variable. When it crosses the equal sign, then its sign changes. If it was positive, it will become negative. If it was negative, it becomes positive. So you can't just cross the equal sign. Crossing the equal sign has got a price to pay. So what is the sign of this? Is it positive A or negative A? So we're looking at this, not this. This positive is for X, not for A. So this is positive A. It doesn't have negative here. And we learned that any number or variable without a sign, it means it has an invisible positive sign. So this is positive A. So positive A, when it crosses to the other side, it will become negative A. So this can be written as this. X, which is this X, equals B, which is this B. And this plus A, when it has crossed, it has become minus A. The question is, where has this plus gone? So the plus is here, but it's invisible. If you want, you can write it, but it will appear that you're a good mathematician if you don't write it, if you make it invisible. So that's how to deal with this case. For some, for who are interested, this case doesn't make sense. It's something that people came up with because it was working. I remember one of my lecturers, when you do this, then he was saying this is not mathematics, so he can't mark you. Reason being, doesn't make sense. It doesn't make sense. It crosses the equal sign, so it changes the sign. There's no logic, but it's something that people came up with and it works. There's another way, a real way to deal with this, but for those who are interested, you can, of course, get in touch with me. I teach you about the other way. But anyway, this is the first test as compared to the actual way. Another situation is here, which is just the same as this case. We have 2 plus x equals b. So to make x subject, we'll take 2 the other side, and since it's positive, it's going to become negative 2. So we're going to have x equals b minus 2. What about this case? X minus 2 equals b. X minus 2 equals b. So just want x to be alone. So 2 has to go this side. But what is the sign of 2? If we see here, the sign is negative. So x minus 2, which means the sign of 2 is negative. This negative belongs to 2. It doesn't belong to x. It belongs to 2. So when 2 crosses the equal sign, it becomes positive. So this will become x, which will remain here, equals b here, and negative 2 becomes positive 2. So let's take a look at a second case, case 2, multiplication case. So multiplication case is a case like this, where our subject, or the thing that we want to make subject, is attached to another variable or number in this way. If you recall, when we have something like this, it means in between there is multiplication. In short, ax is just the same as a times x. That's why this is multiplication. So what happens when something that we don't want is being multiplied by the one that we want to make subject, which is x? How do we remove this? So ax equals to b. To remove this, what you do is you divide both sides by the thing that you don't want, the variable that you want to discard, or the number, if there was a number that you want to discard. So it will become like this. So ax is equal to b. So we have divided by a. So how is dividing going to remove a? You will see. But the rule is, what you do on the left, you should do the same on the right. In the first case, we did not do that. We just transferred the unwanted to the other side. But I say that is something that people came up with. It's not so it's not mathematically, or it's not doesn't make sense. It's not supported by logic, but it works and it is accepted. But in a normal scenario, what you do is you do something to the left side and you also do the same to the right. And in all the cases that we're going to take a look at, that's what we're going to be doing. We'll be doing something to the left-hand side of the cosine, and we'll be doing the same thing to the right-hand side. So in this case, I've said that to remove this a, you divide by a. Why? Because a divided by a, it's 1. Any number divided by itself is 1. So if here there was 1000, we just divide by 1000, because 1000 divided by 1000 is 1. And if we have 1 multiplied by x, it's going to be x. So it means we have made the unwanted disappear. So what you do here, do the same here. So we divided by a, even this side divide by a. So these are going to cancel. So this a is going to cancel with this, and we're going to remain with x. Why is it cancelling? Because a divided by a is 1. So it's cancelling. So, and always remember, this works when this thing you want to cancel is attached to the wanted, not by plus, not by minus, but like this, or by multiplication. That's the only way it works. So when we do this, what you're going to remain with is x is equal to b over a. If you can divide b by a, then you can go ahead. But in this case, we don't know what b is and what a is, or we cannot divide b by a. So we leave it like this. This is our answer. Another case of multiplication is this: negative 2x is equal to b. So again, we do the same. We divide both sides by negative 2. Then negative 2 will cancel, and negative 2 will cancel here. And we're going to remain with x. And on the other side, we cannot divide b by negative 2, so we'll leave it like this. So the reason why I had to show you this case is because some might forget this negative. They might divide by 2. But always keep in mind, this is not 2. This is not, it's negative 2. 2 and negative 2 are two different numbers. So divide by negative 2 so that you remain with x. Here, you should just remain with x. So if you divide by negative 2, negative 2 divided by negative 2 is the same. It's going to be 1. 1 times x is x. So in short, or in simpler ways, we can say negative 2 cancels with itself. So negative 2 has just cancelled with itself. So we're going to have x is equal to b over negative 2. Case 3 is the case that involves division, like this. So we have the subject, or the thing that we want to make the subject, divided by something else equals something else. So we just want to chase this, want to discard this, we don't want it to be here. So what is it that we should do? So this one also, we're going to deal with it like case 1, where there is a shortcut that people came up with and it works. Maybe I can give you an insight into the actual way of dealing with it. So x divided, the over means divided. So x over a is x divided by a. So to remove a, what you do is you multiply this side by a. So it will be a times this side. And this side, what you do this side, you should do the same this side, which means b has to be multiplied by a. If you solve that, you're going to cancel a. I won't show you that because unless you're interested, I can show you that, because the simpler way of doing this is not that. In an exam, you won't have time. So this is the simpler way. So the simpler way is you do what is called cross multiplying. But before you do cross multiplying, you have to make this look like a fraction. But is this a fraction? Yes, it is. Any number without the denominator has got 1 as a denominator. So in short, any number has got 1 as a denominator. Your age, it's a fraction with 1 as a denominator. If you are 35, then your age expressed as a fraction is you are 35 over 1 years. So even this b, it's over 1. So in short, it can be written like this. Now that we have got fractions on both sides, we can do what is called cross multiplying. So cross multiplying involves multiplying this times this and this times this. Here where there is an equal sign, that's where you put your cross. So you multiply a and b and x and 1. Doesn't matter which one you start with. So x times 1 and a times b. So x times 1 is going to be x and a times b is going to be ab. And voila, we have x as the subject. So yeah, I used French there. Voila. Yeah, but this is how to deal with case 3. X is equal to ab. Case 4 involves powers. How do you deal with powers? We have x power a is equal to b. How do we get rid of this a here? We just want to be with x. So x power a is equal to b. How you deal with it is simple. You just introduce the root like this. So if this is a, then introduce the eighth root. I don't know how you call it, but if it was 2a, you can say square root. If there was 3a, you can say cube root, just like that. So if this was 4, you introduce the root of 4 here. So when you do that, mathematically, these two are going to cancel. But remember, what you do here, you should also do on the other side. So these are going to cancel, and the other side you just introduce, because we have introduced square root of a here so that it cancels with this. You do the same this side. So how is it that these are going to cancel? Just believe they're going to cancel. But anyway, for those who don't have faith, these two are going to cancel because of this. So square root of a, x power a, if you remember, or if you can recall indices, is the same as this. How so? X power a, 1 over a. If they have asked you to simplify this, what you're going to do is you're going to introduce the square root of a so that you get rid of this a. So the whole thing is going to be in brackets, then like this, but in brackets power 1. And anything power 1 is just the same thing. So we can forget about the 1. So in short, this and this are one and the same thing. So if you have been given this and you want to express it in terms of a fraction or with a fractional power, you just put brackets, then 1 over a. And if you want to take it back when you're simplifying, you just introduce the square root of a. So I hope you get it here for those who remember indices. So when you have this, what you do is, if you remember the distribution of power law, where we multiply this power times this, or multiplication of powers, so we're going to have a times 1 over a times 1 over a. So what I've done here, I've just concentrated on the top part here. I want to show you how it cancels. So I don't care about the x here because we're just concentrating on this. We want to see if these two cancels. So a times 1 over a. Remember, a has no decimal, is not a fraction, but it is a fraction, and it has a denominator of 1. So it can be written like this: a over 1 times this side 1 over a. If we multiply a times 1, we're going to get a, and 1 times a, we're going to get a. Remember, multiplication of fractions, we do it direct. It's not like addition where we do those strange things of finding the denominator, then multiplying the denominator of the the numerator of the left-hand fraction with the denominator of the second-hand fraction. Anyway, I'm sure you know what I'm talking about because we did algebraic fractions. So once we have a over a, we can cancel a into a. I don't have to explain this. A divided by a is 1. Any number divided by itself is 1. So we're going to have 1. So that's why this cancels. Why? Because this, when you multiply, you're going to get 1. And x power 1 is just x. So this, the whole of it, is going to result into x having a power of 1. And x power 1 is just x. So that's how to deal with powers. So our answer is just going to be x is equal to, I don't know what number is this, root of b. So that's our answer. The opposite is case 5, which involves roots. So that one which we dealt with was powers, but this one is roots, like this. So square root of x is equal to b. So how do we get rid of this part, the square root of a, so to remain with x? The procedure is the same. So what you do is you just put everything in brackets and introduce a, because we know this and this, again, they are going to cancel. So what you do on this side, you do the same here. So you put in brackets, introduce power a. Therefore, this and this are going to cancel. How? The same way I illustrated. So these two are going to cancel. In short, square root of something multiplied by something is going to cancel. Something multiplied by square root of something is going to cancel. You're just going to get 1. So that's a skill that you have to, that has to be part of your intuition whenever you're doing math. So here we're going to remain with x equals b power a. Case 6 is an interesting case which involves brackets. So we have C, then we have open bracket, a plus x cross bracket. Let me just say that again. So C open bracket, a plus x close bracket equals b. So how do we handle this case? So it's simple. First, the first problem is we have x, want to eliminate everything here apart from x. How do we chase them? So we are going to do it step by step. We chase one thing, then we move to another thing. So we have two terms that we don't want, C and A. So we start first by chasing things that are far from A. In this case, C. C is far from A because A and X are inside the brackets. So these are supposed like they are close. So this one has to be chased. How do we chase this? One thing you shouldn't forget is this can be looked at as something like this. So we have C and we have whatever here, because in this case we don't care what is in here, we just want to chase this. Once we chase this, that's when we are going to care about what is in here. So whatever this want to maintain it. So this can be looked at to be the same as C times this which we want to keep equals B. So want to keep all of this. Just for this stage, want to get rid of C. So we have to divide both sides by C. Remember the case that has to do with multiplication. You have to divide by C both sides for you to get rid of C. So we're going to do that, and we're going to have this. So C open bracket a plus x over C, that's divided by C, equals B divided by C. So these are going to cancel, and we're going to remain with a plus x equals b over c. So once we have this, the brackets have disappeared. The job of brackets is to engulf or to separate the things we're interested in from things outside them. So these brackets were just trying to show that these are have to be dealt with or closed, or should be thought of to be like one thing as compared to this C, which is outside. Now that C is not here, then the brackets have no purpose, so we get rid of them. We don't show them the next step. So now that we have this, what can we do? So this is case 1, the additional case, where something we don't want is adding to x. So what do? It crosses the equal sign and becomes negative. So this is going to be our x maintains equals b over c, and this is positive, so it's going to be minus a.